I would like us to discuss set theory. Set theory is a very important topic in this class, SS3, because it is external examination delight. So I would like us to start from this number that said I should write down the elements of the following sets. When they say write down the elements of a particular set, they are saying that I should write down the members of that set. The sets are P, prime numbers less than 40. Q, prime factors of 120 less than 40. R, square numbers less than 40. S, multiples of 5 between 0 and 40. After you have listed the members of these sets, then evaluate Q intersection R, R intersection S, Q union R, P union S. So we have to go and name the members of the sets listed. The first one is P, and they say prime numbers less than 40. You first of all ask yourself, what is a prime number? A prime number is that number that is only divisible by itself and 1 without a remainder. That number that it is only 1 and itself that can divide it without leaving a remainder. That is what we call a prime number. So bearing that in mind, you will be able to list the prime numbers between the prime number that are less than 40. Let me cite this warning. 1 is not a prime number. Students do make the mistake of including 1 as a prime number. 1 is not a prime number because 1 did not satisfy the characteristics of a prime number, being that number that only itself and 1. So if you remove 1 from itself, there won't be 1 again to remain. Or if you take 1, there won't be itself again to remain. So that is why 1 is not a prime number. So the prime numbers now are 2 is one of it, 3 is one of it, 5 is one of it, 7 is one of it, 11, 13, 17, 19, 23, 29, 31, 37. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you look at these numbers, it is only 1 and themselves that can divide them without a remainder. So these are the prime numbers that are less than 40. The second one is Q. Q is prime factors of 120 less than 40. Prime factors of 120 are simply those prime numbers that can divide 120 without a remainder. those prime numbers that can divide 120 without a remainder. Think about them. 2 is one of it. 3 can divide 120 without a remainder. 5 can divide 120 without a remainder. 7, 11. This set has only 3 members. It is only 2, 3, and 5 that are prime numbers and also factors of 120 between that are less than 40. So the next one is R. R, members of R are square numbers less than 40. Square numbers less than 40. Square numbers are those numbers that has integers, whole numbers that are their square roots, and they are square roots of integers. Square root of whole numbers is either they have integers as their square roots, they have whole numbers as their square root, or they are square roots of whole numbers, square root of integers. So think about it. 1 is one of it. 1 is a square number because 1 is a square root of 1. After 1, we have 4. 4 is a square number. After 4, we have 9. 9 is a square number. After 9, we have 16. 16 is a square number. After 16, we have 25. 25 is a square number. After 25, we have 36. 36 also is a square number. So these are the square numbers that are less than 40. The last is S. Members of the set of X are multiples of 5 between 0 and 40. Multiples of 5 are those numbers 5 can divide without a remainder. So begin to think about it between 0 and 40. Multiples of 5. 5 is one of it. The next is 10, 15, 20, 25, 30, and 35. Between 0 and 40. 0 and 40 exclusive. So these are the multiples of 5 between 0 and 40. So these are the elements of the sets as the question has asked. Now we are to now evaluate A, Q intersection R. Q intersection R are those members of Q that are also members of R. That's what we mean by Q intersection R. Those members of Q that are also members of R. So question number A, Q intersection R. The members are going to be, just go to Q. This is Q, this is R. Any member you find here that you also find here. There is no member of Q that is a member of R. So that set is an open set. There is no member there. B. B said R intersection S. those members of R that are also members of S. Let's check. I could see 25. So 25 is the only member of R that is a member of S. R intersection S is only one member, and that member is 25. Now C. C says Q union R. All the members of Q that are also members of R. All the members of Q and all the members of R. Not that are also members of R, but all the members of Q and all the members of R. The only thing is that don't repeat any of the members. Q union R. This is Q, this is R. We have 1. We have 1, 2, 3, 4, 5, then 9, 16, 25, and 36. This is Q union R. All the members of Q and all the members of R. The last but not the least is the P union S. P union S. All the members of P and all the union members of S. This is P and this is S. So let's go. We have 2, 3, 2, 3. We have 5, we have 5. So big 1, 5. We have 7 before 10. So 7, 10. We have 11. 13 before 15. We have 11, 13, 15. You have 17, 19, 20. 17, 19, 20. We have 23, 25, 23, 25. We have 29. 29. I have to continue here because of space. 29. Now 30, 31. We have 30. We have 31. 30, 31. Then we have 35, 37. 35 and 37. So these are the members of P union S. All the members of P and all the members of S. But don't repeat any of the members, assuming they occur in both sets. Don't write any particular number twice. So this has brought us to the end of question number 1. If the universal set, this is a symbol of the universal set, we call it universal set. So if the universal set is equal to whole numbers up to 20, that is from 0 to 20, and members of set A are factors of 15, those numbers that can divide 15 without a remainder. Members of B are factors of 18, those numbers that can divide 18 without remaining anything. C, factors of 12, those numbers that can divide 12 without a remainder. D, prime numbers less than 10. Those numbers that has only themselves as 1, as numbers that can divide them without a remainder, between 0 and 10. That is less than 10. Remember, 10 is not inclusive. So now they say A, write down the elements of each set. We should write down the elements of this set. Then find A intersection D, members of A that are found in D. That is members of A set that are also members of D set. B union D, all the members of set B and all the members of set D. C union D prime. D prime is those members of the universal set that are not found in D set. We call them D prime. Those numbers you find in the universal set, but if you come to D set, you will not find them. We call them D prime. So if you write D prime down, you now get C union D prime. That means all the members of C and all the members of D prime. The last is bracket C union D prime. That is when you, if you find all the members of C and all the members of D, now you keep it and find the members of the universal set that are not found in the members of C union D. That is what we call C union D in bracket prime. So we're going to do all these things one after the other. First of all, the universal set. We have to manage our space. The members of the universal set are 0, 1, 2, 3, 4 till 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is whole numbers up to 20, from 0 till 20. That is our universal set. Now, members of A set. Let me write here because of space. Factors of 15. All those numbers you find in the universal set that can divide 15 without a remainder. 1 is one of them. 3, 5, and 15. So we have 1, 2, 3, 5 members. 1, 3, 5. 1, 3, 5, and 15. 4 members, sorry. 1, 2, 3, 4. 4 members. Now, set B. Factors of 18. Those numbers that can divide 18 without a remainder. 1 is one of them. 2 is one of them. 3 is one of them. 6 is one of them. 9 is one of them. And 18. 1, 2, 3, 4, 5, 6. These are the numbers that can divide 18 without a remainder. C. Factors of 12. Those numbers you can find in the universal set that can divide 12 without a remainder. 1 is one of them, 2 is one of them, 3 is one of them, 4 is one of them, 6 is one of them, then 12 is the last number. 1, 2, 3, 4, 5, 6. These are the numbers that can divide 12 without a remainder. Now D. Members of D are prime numbers less than 10. Those numbers that can divide themselves, that is only themselves and 1 that can divide them without a remainder. Remember, 1 is not a prime number. The first one is 2, 3, 5, and 7. So these are prime numbers that are less than 10. So we have answered question number A. This is our question number A. Of our question. Part B says we should find A intersection D. All the members of set A that are also members of set D. That is the meaning of A intersection D. So our A intersection D is going to be, just go to A and look at D. All the members that you can find in A and can also find them in D. 3 and 5. There is 3 here, there is 3 here, there is 5 here, there is 5 here. So the members of A intersection D are 3 and 5. The second one is B union D. All the members of set B and all the members of set D. B union D. This is members of set B and these are members of set D. 1, 2, 3. Just don't repeat any number. 1, 2, that's 2 here, that's 2 here, 3, then 5, D, B, and D. I'm taking 5, now 6, 6, 7, 9, 18. So these are the members of B union D. Now C union D prime. Before you go into this, first of all, find D prime. D prime are those members of the universal set that you will not find in set D. D prime. So we have 0, 1. D is 2, 3, 5, 2. 2, 3, 5, 7, sorry. So we have 0, 1. 2 is here. 3 is here. There's no 4 here, but there's 4 in the universal. So we bring in 4. 5 is here. There's no 6 here, but there's 6 here. So we bring in 6. There's 7 here. 7 here. Then from here till 20, we have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So these are members of D prime. Members of the universal set that are not found in D are called members of D prime set. Now let's now go into C union D prime. C union D prime. C union D prime are members of C and members of D prime. Members of C and members of D prime. So let's start. 0, 1. So we have 0, 1. That's 1 here. 2, 3, 4. 2, 3, 4. 2, 3, 4. That's 4 here, that's 4 here. Then 6, 8, 9, 10, 11, 12. 6, 8, 9, 10, 11, 12. Okay, after 12 now, then from 13 till 20. So we have 13, 14, 15, 16, 17, 18, 19, and 20. So these are members of C union D prime. Please, I want to clean up this so that we can continue the next. So let's just write this till 20. You understand what it means. All right. Now the last but not the least is C union D prime. So first of all, you will find C union D. Then when you find C union D, or have you found it here? No, we have not found C union D. So if you find C union D, whatever members you have in C union D, C union D prime will not be those members of C union D. Sorry, the members that are found in the universal set that will not be found in C union D. So first of all, what we're going to do now is we're going to find C union D. We keep it. Then we'll now look into the universal set. Any member of the universal set that could not be found in that C union D is the C union D prime. So first of all, let's find C union D. All the members of C and all the members of D. C and D. So 1, 2, 3, 4, 5, 6, 7. So let's write that one first. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then 12. So this is C union D. C union D prime. C union D prime. So it's going to be equal to all the members of the universal set that could not be found in C union D, which is this. So let's look for them. 0 is in the universal, it is not found here. So 0 is the first number. So we have 1, 2, 3, 4, 5, 6. Now 7. So we have 8, 9, 10, 11. 8, 9, 10, 11. That is 12 here. Jump 12, then from 13 till 20 is the remaining members. 13, 14, 15, 16, 17, 18, 19, and 20. So these are members of C union D prime. And that has brought us to the end of question number 2.